Hi, this is Mark Ray from Hewlett Packard Enterprise. I'm here today to introduce an advanced Linux performance analysis tool called the LinuxKI Toolset, or LinuxKI for short. LinuxKI was developed by Hewlett Packard Enterprise to redefine how we troubleshoot performance problems on Linux. We've been using LinuxKI for the past 7 years to solve difficult performance issues, often with surprising accuracy and speed. In 2017, we introduced LinuxKI as open source software to allow the Linux community to share in the development and the use of LinuxKI. While there are many existing Linux performance tools available today, many of them will show symptoms of a performance issue, but they lack the details to understand the root cause. Often, it's like investigating a crime scene. The detectives can go in and investigate the scene and make some educated guesses, but there's a lot they cannot tell from the naked eye. They need forensic evidence, fingerprints, fibers, and DNA to help solve the case. Meanwhile, there are some good forensic tools on Linux, but they can often be difficult to use. This is where LinuxKI comes in. It is an easy-to-use, trace-based performance analysis tool that has the ability to micro-analyze the system behavior in order to take out the guesswork and help identify performance issues quickly. The idea behind LinuxKI is that a Linux environment consists of a collection of user and system tasks. A task, also called a thread, is typically only in one of two states. Either the task is executing code on the CPU, or it is waiting for something, such as disk I/O, data from the network, mutex, semaphore, or we're just waiting for its turn to get CPU. So the key to troubleshooting performance is to be able to answer the following questions for each task. When it's running, what is it doing? And when it's waiting, what is it waiting on? With LinuxKI, we can also see the interaction between the running and sleeping threads so that we can understand how threads compete for resources or coordinate for work. One of the key reports generated by LinuxKI is the PID analysis report. This report contains detailed information on every task that ran during the trace period. For the task analyzed in this demo, we can find a wealth of information for the 20-second trace period. Here, we can get scheduler details, which gives us an overview of how the task spent its time, CPU metrics, and CPU run queue latency information for the task. The cooperating and competing tasks section provides information on the other task that this task cooperates with or competes with. The sleep report helps answer the question, when it's waiting, what is it waiting on, by providing function names and stack traces where the task slept. Note for this task, most of the sleep time was due to an ext4 file mutex. The CPU activity report provides CPU profiling information on the task to help answer the question, when it's running, what is it doing? Note that we can see the hot functions along with the associated stack traces. Finally, we get other detailed information on system calls, file activity, I/O activity, or network activity if there is any. Remember, this information is provided for every task that ran during the trace period. While we get detailed statistics for each task, we're only scratching the surface. LinuxKI also uses trace data to generate global CPU metrics, disk I/O statistics, network statistics, interrupt statistics, and much, much more. And all of this is performed with two simple scripts. If you'd like to learn more about LinuxKI, check out the LinuxKI wiki page, where you'll find easy to install packages, as well as LinuxKI documentation, which includes the quick reference guide, a frequently asked questions, and a detailed reference manual. Finally, be on the lookout for additional LinuxKI videos, as well as updates on the LinuxKI wiki page. Thank you for your time today, and I hope you'll be interested in learning more about LinuxKI in the future.